All right, so final unit activity of the semester. We're going to do system of linear equations. Oh my gosh, my pen's broken. Hold on, guys. Need to find a point. All right, so we're going to be doing systems of linear equations and inequalities. So this is going to involve like more than one scenario that we need to see where they meet up and things. So our goal is to be able to write the system of equations that represents the real world data problem. So in this, we're going to be talking about Aiden and Natalie, and they're going to create these catapults. And these catapults involve the arm, so how long the arm is. And it's so that's going to be our x value. This is going to be our independent variable. We don't know like how long they want to make their arm. Our dependent variable is going to be y. It's going to be how far the ball travels. So obviously, it's the reason why it's dependent is because it's however long the arm is going to affect how far the ball's going to fling. So they're launching tennis balls. All right. So we're going to use technology for this. So there's going to be a few things that we're going to need to do technology-wise. All right. So when we're doing this, they give us all this data. So it seems like it's a lot, but it's actually not that bad. We need to find this equation for it. So we're actually going to use this graphing tool right here. A lot of people skip it when they're doing this activity. They don't see that, like, oh, we need this graphing tool. So first things first, I'm going to copy all of the data from Aiden. So this is all of Aiden's data. Open up this graphing tool. And I'm going to put this in the data column. So I'm going to add data, Control V, and this automatically puts all of the data there for me. And then I can click plot, and it gives me this line right here, all these points right here. And it wants us to find the line of best fit. This is the cool part. So instead of kind of like guessing, like, let me put the line here or whatever, this actually has a tool that lets us do that. What we would do is we want to find the relationship between it. So we're going to add a relationship. We want it to be a linear relationship, a straight line. So we're going to say linear. And we're just going to click best fit. And this automatically makes the line best fit. If we counted them, we would have the same amount of dots under line as the same amount of dots over the line. So 1, 2, 3, 4, 5, 6, 7 under the line. 1, 2, oh, I guess not the same amount of dots, but the same distance. So the distance, because this one's so far away, kind of takes the place of a lot of dots. So I misspoke on that. I'm sorry. But this would be like a good way to kind of predict it. So, and it spits out the information right here. So here's our function. So now when we go over here, all we have to do, well, I have it answered, but you guys can get it. All we have to do is just plug this in. So normally it would look like this. What's our m? Our m is our slope, our rate of change, and that's going to be right here, this 2.3. And our b is our intercept. That's where it's going to touch the x-axis. We can't see it right now, but if I zoomed out, oh, apparently it doesn't want to ever do the zeros. But if I were to zoom out on the normal tool, we would see that's where it kind of crosses this. So basically, it's not realistic, but if the arm was 0 feet, the ball would still go. But like I said, the numbers are weird. So we're just going to change this to a 2.3, and our intercept is 106.7. So now we want to do it for Natalie. So we're going to do the exact same thing. All we're going to do is just copy this, open up another graphing tool. You'll notice it says part B. So this is good to like have when you're answering the questions. That way you know which one's part A and which one's part B. We're going to do the same thing. So I'm going to move this out of the way, put data, plug my points in, plot it. We want a relationship, so we're going to go relationship linear, click that little best fit box, and it calculates our new slope. So when we're doing this, we need to make sure that we're doing it to their specifications, and they want it to the nearest tenths. So the tenths is 1 decimal place. So when we do this, it's going to be, make sure you're on part B, 3.6, not 3.58. I've had to take points off because it does tell you to do 1 decimal place. And then 202.6. So that's how we get that, just using technology. Even Desmos has a best fit tool. So I'll leave this one to you guys. Is the statement true? So we're going to have to look at the graph at 55, see how far that is. So you're going to write down, this is part A, so this one is Aiden's. And then we're going to look at Nataly's, which is in part B. So again, we're going to go to 55 and kind of guess where Nataly's ended up. So that one, you guys should be able to do that on your own. 55 meters per second. And you're going to have to look at like the slope and the distance and all of that to help you answer this question. So I think that's a fair point to get that by yourself. The next one, it wants you to find the correct answer. So what we're going to do here is we have 2 lines. One of them was y equals, I'll do part A first. 2.3 2.3x plus 160.7. And the other one was 3.6 x plus 202.6. So if you guys remember from the Kahoot, there's a few things we can do. We can do elimination, or we can do substitution. Since they're both set to y, I think substitution's better. You're just going to make the y's the same thing. So you're going to go 2.3x plus 106.7 equals 3.6x plus 202.6. And what you're going to want to do is you're going to want to get all of your x's together. 1.3x, 7, 6, and you're going to want to subtract these to get all the regular numbers together. If you need a calculator, you can always just pull up the calculator right here on the side. So 106.7 minus 202.6, and I just realized I didn't have it typing. If you guys would have your mics on, you guys could tell me that I wasn't typing it. So 41.9. So negative 41.9 is equal to 1.3x. So we're going to divide that by 1.3. Divide 1.3. And you get negative 32.2. So now we have our x value. So that's going to go right here, negative 32.2. We need to find our y value. It doesn't matter if you plug it into the x into this one, and it doesn't matter if you plug it into that one. So this I will let you guys do on your own. I trust you guys can just plug it in. So you're going to do y equals whatever slope you guys chose times this plus whatever the b value is for the equation you chose, and just solve it from there. All right, so the solution. So you need a, I solved for x, and x was a negative number, right? We got this here. So analyze the solution, determine this. What we want to think here is we're thinking, again, I didn't solve for the y value, but we don't need it to solve for part E. Analyze the solution. If x represents how long the arm is, you know, can we have a negative length, right? That doesn't make any sense. You can't have a negative arm length. It can only be positive. So what we would say is we would say something like, even though there is an answer, that answer is not realistic. So they would meet right here. So that's the only spot where they would have a distance, but it happens at what would be a negative arm length, meaning that these balls will technically never travel the same distance. Because of the fact that Aiden's, I believe, has a smaller slope, that means Aiden's ball will always fall short of Natalie's. So if we look at that, part A, we see that like at 55, Aiden's going at like, I don't know, like 290 ish, while Natalie's going at like 400. So Aiden's is basically always going to be shorter than Natalie's, because the only time these lines would have crossed would have been at a negative thing. So Natalie's is just better. And you can write stuff like that down. Natalie's just throws it a lot better. No matter how long her arm is, it's going to be better. The only time it would have been worse is if there's a negative arm length, which can't even happen. All right. And that's it, guys. So just write that down like in your own words.